Okay, so yeah, we are back, and this continues from the previous part. Right, so we have the open bracket, like the curved one. Like it may be on the left, it may be on the right, it may be on both sides, and we say it's open because we don't include that point. That point is like gone. We leave it. We leave it away, and we have the closed one. And let's screen. It says inclusive. Like it includes the point itself. It includes the point A or includes the point B, yeah, depending on which part we put it on. And so say it's closed. Right, so it could be open or closed, and that corresponds to various intervals. And before we move on, just a note that sometimes this notation can be seen like somewhere else. Like for instance, this AB could be a point. You could talk about point A or B, or maybe the interval here. Maybe just array. If you study computer scientist or if you code, right? So make sure that whenever you see this notation, you think about what it could mean. Is it an interval, or is it just a point, or is it an array? Just a word of fun. But in this case, like for this class, like this thing means interval. And also, I'm gonna make sure to include that. Okay, we talk about interval. I'm gonna include a word in front so you don't mistake that for something else. So these are intervals, and we express them in terms of set. Another way, which is a better way to visualize these sets or these intervals, is as a line on the as a block on the line. So let's start from the top one. We have the open interval 0, 4. Now in this case, if you translate back to numbers, it means you are looking at all the numbers between 0 and 4. Not including 0 and 4. So they are open. Right? And when we think about open interval, the way we write or the way we express that interval is as a line from the smaller one to the higher one. And then we write a circle, a blank, or like I think it's called not a blank circle, but a hollow circle with a hole to indicate that we don't have that. That's not the point. Like we don't include that point. That point is, removed or it disappears. But on the other hand, let's keep there to the closed interval, the fourth one. If you talk about the closed interval from 0 and 4, and we still draw a line from 0 and 4, but now we write a full point or a full dot or a filled dot. Yeah, let's say fill, to indicate that we mean that we include 0 and 4. 0 is in this interval, like in this range, and 4 is also in this interval. It is also in this range. Right, so that's the open, that's the close. Right, and as you saw above, sometimes we have half open, half close. Like open on the left, close on the right, or close on the left and open on the right. But as long as you draw a dot in the correct fashion, like if it's open, you draw a hollow dot. If it's closed, you draw a filled dot. Then you should be fine. And there are two special intervals that we use a lot. So sometimes it has like a non-ending interval. And instead of having left and right, sometimes that's only the left one. And there's only the or in this case, for the top one, there's only the right one. Right? Only the right interval is there. In this case, it means we are looking at all the numbers and it's less than 4. Like starting at 4, but not including 4. And then go all the way to the minus infinity. I just keep continuing on the left. So that's the non-ending interval. You just keep on forever. And also, we can have an interval that has the left part, but not the right part. So we have the smaller number. In this case, for this one it's 4, but we extend to the right indefinitely, right, to infinity. And in this case, you have to, read the graph or read the notation. But this is a closed interval, and the closed means we include that twice. We also allow x to be equals to that number or that endpoint. So these are for +2, I guess 6 ways you can describe intervals. And again, it is also kind of a set, but it's a set of numbers between two numbers. So yeah, those are intervals. But the thing is, since they are sets, that means we can do some operations on them. For instance, given the set A, B, C, D, like these 4 sets, we can do the usual set operations on them. And let's see if we can do that. Right, so let's start from A intersects B. Right? If you try to write that in terms of, Venn diagram, that doesn't work. That's not how this works. Right, so we have to use a different way to express these two sets. In this case, we can express them on a line. Or maybe let's put them all on the line, like for reference. Like what are the numbers we have? 0, 1, 1, 2, 3, 4, 5, 6, and then 7. So there are 7 numbers. The set A spans from 0 to 4. So usually we would write, 1 to 4, 1 and 4. And since they are both closed, right, we fill the dot and then connect these 2 dots. This would be an interval A. But sometimes there are more than 2 intervals, and if you write everything on the same line, that would be confusing. Right, so we can improvise and move the dots and line a little bit above. It is getting slower. Oh, okay. Yeah, so we can write this way. Right, so move the dots and the lines a little bit on the top. That's how you express the set A. Yeah, and then let's continue. Yeah, the set B would be from 0 to 5. Are they closed or open? They are both open, so we leave the dot hollow and connect them. This will be the set B. Next, we have the set C from 3 to 6. Right, we have 3, we have 6. 3 is open, so leave it there. 6 is closed, so we fill it up. And connect these 2 dots. This would be the set C. And finally, the set D. We don't have space for that. Yes, no, let's write it below here. Now it's from 0 to 7, and they are both closed, so we fill both ends of this interval and connect them. And there, this is the set D. Alright, so now that we visualize these 4 intervals, let's see how we can operate them. Alright, so we want to find A intersects B. And again, we have to go back to the definition of what it means to intersect 2 things. Right? It means we look at points or we look at paths that are on both A and B. Right? In this case, look at numbers that are both in the interval A and in the interval B. And the nice thing about this is we can visualize that visually. Right here, for the number would be in B and A. If you start here and then you go up, and then you hit B and then you hit A, that means that number is on both A and B at the same time. So it's nice visually. So let's do one detail examples here. So we have A from 1 to 4. We have B from 2 to 5. They are open. Now, how do we represent the set or the interval A intersects B? Like we look at all the parts that are on both sides, on both lines, right? For instance, this part, like it's pretty obvious, right, that it is on both blue and the pink one, right? That number, all numbers on this line, like it's on the blue line and on the pink line. When the issue is the endpoints, like we have to be careful about the endpoints. So what about 4? Is 4 in the interval? Like the answer, if you think about it, like 4 is on the blue line, like 4 is in B, like for sure. Is 4 is in A? Is 4 in A? Yes, it's in A because it's closed, right? Because the set A includes the number 4, and so we fill the dot. So this part, like, is A in A intersects B. But on the other hand, if you go to the left and see this dot, right, so it stops here, right, for sure. And then you ask, is 2 in the intersection? Is 2 in B and A at the same time? The answer is not, because 2 is not in B. Like by the definition of B, like B is open on the left side, so 2 is excluded. It's not included. So that's A and B for us. That's A intersects B, which we can write in terms of interval as open 2 and then close 4. So this is how you find intersection of two intervals using intervals. You do it visually. Next, let's try union. How do we add two intervals together? We have B and we have C. Right, and then if you look at B and C, let's copy it here, B and C. B is from 2 to 5, and then C is green. Oh, I should not use green. Anyway, C is from 3 to 6. For union, we look at all the points that is in either B or C. So we kind of add them up together. Right, so a point or a number is on B union C if it's on B or C. And again, this part is obvious, right, because this part are in both B and C at the same time. But what about this part? Should it be on the union? Maybe I should put C there and B there. Now the answer is yes, it should be on the union because it's on C. And because this set, like this union, includes the points that are on either B or C or both. It's on C, so it works for us. And it is on C all the way up to this endpoint, which is 6. Right, 6 is on C, so it has to be on the union. On the other hand, we can look at the left part. This part is on B, right, so it's on B union C. But the endpoint here, the 2, is not there. Right, so this is the result that we have is B union C, and that's this. It is this intervals, this whole interval. And if you convert that into the interval notation, you get 2 all the way to 6. That's the union. Yeah, that's the union. Next is the minus. This is let's say challenging. Like not that confusing, but challenging. So we start from. If you go back to the definition, it means we start from A, like 1 and 4, and then we remove everything that is on C, and here C is from 3 and 6. Right, so you can think of it like this line, like you start here, and again we remove part that is on C, and here this part is on C. It's pretty obvious it's on C, so we're gonna have to remove that part. Right, but the part that you have to think about it for a little bit is number 3. Right, we remove everything from 4, right, because 4 is on C, so it needs to be removed. It needs to be subtracted out of the set A. What about 3? Should 3 be removed or not? Should that be hollow or filled? Like open or close? And again, I go back to definition. Right, you remove everything that is on C. Is 3 on C? Like is number 3 on the set C? No, C3 is not on the set C. That means we don't remove C. We don't remove number 3. number 3 stays on the line. So that means we remove everything, right? That is from 4 up all the way down to 3, but not 3. We still keep 3. And that means here is our set minus. Like this A, this pink minus the green one results in the blue one. And in set notation, it is starting from 1 all the way up to 3 and is closed. Because 3 is in the set. 3 is in A, but not in C. Right, and yeah, finally, let's go about that for real quick. As we have D. D is, as you can see, D is pretty large. Right, D is from 0 to 7, and then C is between is 3 to 6. Right, what happens when you subtract D from D? Then again, it's like you start from D. You start from D, and then you remove everything that is on C. So that means you remove this part, this part, this part, this part. Right? You remove everything that is on C. Remove this part, like this middle part. This point, which is 6. 6 is on C, so you remove 6 as well. And once you remove 6, you are left with just a hollow dot. Right? 6 is gone, 6 is removed. But on the other hand, like for the left side, right, you remove everything, but not this part. This part is 3. And you don't remove this point because this point is not on C. So you keep it there. You leave it on the set. And so in this case, what we are left with are 2 different intervals. We have the interval on the left, which can be written as the closed interval from 0 to 3. And then we have another interval on the right, which is the interval from 6. Oh, that should be open, right? Because we remove 6 from the interval up to 7. And since we have both, like we don't split them into 2 different intervals. Like these 2 intervals represent the same set. They represent the same sets of numbers. Then we have to put the union between them to specify that the result has 2 parts, and these 2 parts are the same set. They belong to the same set of D minus C. And so that's the result of the set operations on intervals. And yeah, I think that's a good time to stop.